Dear all, the last few videos I explained the concept of low pass filter and high pass filter. A low pass filter passes only low frequency signals and blocks or attenuates all high frequency signals. A high pass filter passes only high frequency signals and blocks or attenuates all low frequency signals. In this video, let us discuss the concept of band pass filter. A band pass filter passes a band or the range of frequency signals and blocks or attenuates the signals outside this band. Suppose if I want to pass the signal frequencies between 1 kHz to 10 kHz, and if I want to block the signal frequencies below 1 kHz and above 10 kHz, then I can use this band pass filter. This band pass filter is very useful in communication systems. So types of band pass filter, they are classified into mainly two types: wide band pass filter and a narrow band pass filter. The classification is based on quality factor of the circuit. If quality factor is less than 10, then it is called wide band pass filter. If quality factor is greater than 10, then it is called narrow band pass filter. So we know that selectivity of a circuit is equal to quality factor by bandwidth. So quality factor defines, or it gives an information how pure the inductor or the capacitor which is used in the filter or the circuit. So if we say that the capacitor is a pure capacitor, we say that the quality of the capacitor is very good and quality is high. If quality is high, selectivity is high. If selectivity is high, so obviously bandwidth will reduce, because selectivity is inversely proportional to bandwidth and directly proportional to quality factor. So if quality is high, selectivity is high and reduces the bandwidth. So in this case, I have shown two graphs here, but in this case, so bandwidth is very less. Bandwidth means the range of frequencies between F1 and F2. So if you want wide bandwidth, if you want larger, so selectivity should be less. Less selectivity means less quality factor. Like that, depending upon the quality factor of the circuit, we can get either wide band of frequencies or narrow band of frequencies, and accordingly the filters are classified. Now, a band pass filter can be constructed by using one low pass and high pass filter. So now let us take this. So here in this diagram, I have used one high pass and low pass filter, both connected in cascade. Cascade means the output of one stage is connected to the input of other stage. Here, let the cutoff frequency for a high pass filter is 1 kHz and that of low pass filter is 10 kHz. Then what does it mean? If I say cutoff frequency is 1 kHz for high pass filter, it means that it passes the signal frequencies above 1 kHz. Below 1 kHz, it rejects the signals. Suppose if I say the cutoff frequency for low pass filter is 10 kHz, what does it mean? It means that this filter passes the signal frequencies up to 10 kHz, and above 10 kHz, it blocks the signal frequencies. So this is the frequency response of high pass filter. This is the frequency response of low pass filter. Suppose if I connect these two in cascade like this, what happens? So this fellow high pass filter, so cutoff frequency, so FC is equal to 1 kHz, means this fellow will allow or pass the signal frequencies only above 1 kHz. Up to 1 kHz, this fellow will block the frequency signals. Such a signal frequency is given to low pass filter. What this fellow will do, since cutoff frequency is set to 10 kHz for this filter, this fellow will allow all the signal frequencies up to 10 kHz. So output of this is above 1 kHz only you are going to get the output here. Such a input is given to low pass. This fellow will allow the signal frequency up to 10k, hence the resultant frequency is 1k to 10k. So we are getting a range of frequencies between 1 kHz to 10 kHz. Like that, we can realize a band pass filter using one high pass and low pass filter in cascade. Now the combined response of these two gives the total response of this band pass filter. So this is the frequency response of this band pass filter. You can see here F1 is the lower cutoff frequency, F2 is the higher cutoff frequency. F1 is in this case 1 kHz, F2 is 10 kHz. So it passes the range of frequencies between F1 to F2, and this is called pass band. So below F1 the gain is falling, above F2 the gain is falling, which means that below F1 and above F2 the signals are attenuated or it is blocked. And if you see this response is similar to this response. And if you see this side, the second part, this response is similar to this response. So this response is for low pass filter. This response is for high pass filter. Hence, this band pass filter acts as high pass filter at low frequencies. This is low frequency signal. So at low frequencies, this acts as high pass filter. At high frequencies, this acts as low pass filter. Hence, the combined response gives a band pass filter. Now let us look into the circuit diagram. Now here, if you want to construct a first order band pass filter, we need to use first order high pass filter and low pass filter. Suppose if you want to construct second order band pass filter, then you have to use second order high pass and low pass filter in cascade. Now let us discuss the first order band pass filter for our syllabus. Now this is the circuit diagram for a first order band pass filter. So this is first order high pass filter circuit, already we discussed. This is the first order low pass filter. So both are connected in cascade. Then this results in a band pass filter. Already I explained the concept. Now we need to discuss only the gain equation here. We know that for a low pass filter, the voltage gain formula is given by AF divided by, you can see here, so AF divided by 1 plus F by FC whole square, which we derived in the last video. And this is the voltage gain formula for a high pass filter, that is AV is equal to AF into F by FC divided by root of 1 plus F by FC whole square, where FC represents the cutoff frequency. So here FC is the cutoff frequency, here also FC is the cutoff frequency in low pass and high pass filter. Since you are connected in cascade, the total gain of this circuit, that is band pass filter, is the product of individual gains. Now since this filter acts as high pass filter at low frequency and low pass filter at high frequencies, hence this cutoff frequencies, instead of FC and here FC, we have to take F1 and F2. So let the lower cutoff frequency be F1 and higher cutoff frequency be F2. Hence in this formula I am replacing F1 and F2 here. Then you will get this equation. Now I have to take the product of these two. Now let us take the product of these two here. So if I multiply both the gains, we get a combined gain, that is product of individual gains of low pass and high pass filter. So if you multiply this, you will get this equation. Here AF into AF gives AF square, that I have taken it as AFT, that is total gain. AFT represents, so here AFT represents AF into AF, where this is the pass band gain of low pass filter, this is the pass band gain of high pass filter. Okay. Now this is the total gain of this band pass filter. Here F1 represents the lower cutoff frequency, F2 represents higher cutoff frequency, where F represents the frequency of the input signal. That's all. Next, if you want to design this filter, it is very simple. You have to design individually low pass and high pass filter as we designed in the first order low pass and high pass filter. For example, if you take f1 equal to 200 hertz, f2 is equal to 1 kilohertz. If I want a pass band between f1 and f2 1 kilohertz, how to design this band pass filter? So data given, f1 equal to 200 hertz, f2 equal to 1 kilohertz. So total gain required is 4. First, what you have to do? You have to design a low pass filter, because at high frequencies, the band pass filter acts as low pass filter. Hence, to design a low pass filter, take the cutoff frequency as f2, because so at high frequencies, band pass filter acts as low pass filter. Hence, taking the f2, that is high cutoff frequency f2, we need to design the low pass filter. So low pass filter is this is a circuit diagram of a low pass filter. This is a circuit diagram of high pass filter. What you have to do? You have to design this filter. First, you have to assume capacitor. How much we are going to assume capacitor? Less than 1 microfarad, as we did in the earlier design. So in this case, you can take a 0.01 microfarad standard value. You can see here, take 0.01 microfarad standard value, then calculate the capacitor. You know that frequency formula, cutoff frequency formula, 1 by 2 pi RC, where here R is R dash, C is C dash. Then calculate R, you will get 15.9 K. That's all. So that completes the design of R and C of this circuit. Similarly, to design this, you take cutoff frequency as F1, because at lower cutoff frequency, this circuit acts as high pass filter. Therefore, so take Fc equal to F1 to design a high pass filter. As usual, assume capacitor 0.05 microfarad, or you can take 0.01 also. So to get a good performance, so it is assumed in the standard textbook this value, hence it is shown as it is. Then R we have to calculate 15.9 K. Since passband gain A of t is given as 4, A of t is given as 4. What is A of t? So A of t is equal to AF into AF, where AF is the passband gain of low pass filter. This is the passband gain of high pass filter. This passband gain completely depends upon the values of R1 and RF. So what is the formula for a passband gain? It is equal to 1 plus RF by R1. So we know that. So passband gain AF is equal to 1 plus RF by R1. That is, if I take this as 2, so this must be 2, this must be 2, 2 into 2, 4 I want. Hence, the passband gain of low pass filter is 2, passband gain of high pass filter is also 2. To get to this as 2, then what we want, we have to take RF equal to R1. If RF is equal to R1, 1 plus 1 becomes 2. When RF is equal to R1, we need to assume here. You can take 10K, 10K, here also 10K, 10K. That gives the passband gain for this problem. So given problem, we want passband gain of 4. Next, what is been asked in this? We need to calculate the quality factor also. Quality factor of the filter. So quality factor of the filter formula is, you know, Q factor is equal to F0 by bandwidth. What is bandwidth? Bandwidth is equal to F2 minus F1. That is 800 Hertz. Substituting F0. What is F0? Root of F1, F2. So calculate this. Substitute here, we'll get the quality factor. That's all. It is very simple to design. Just to conclude the design, first in this case, you are designing low pass filter, high pass filter individually. Assume capacitor, calculate R using the formula F equal to 1 by 2 pi RC. How much capacitor you are going to assume here? 0.01 microfarad, calculate R. Similarly here, assume the capacitor, calculate R. In this case, we are assuming capacitor 0.05 microfarad and calculating the value of R. Once you get that, so take RF and R1 same, RF and R1 same. You can take 10K, 10K as, so that it gives the passband gain for this as 2, for this also 2. So 2 into 2, 4 is the total passband gain we want. Like that, we can complete the design of this filter. Thank you for watching.